In a groundbreaking revelation that could change humanity's place in the cosmos, NASA has announced the detection of the first-ever extraterrestrial signal coming from the direction of Proxima B, the closest known exoplanet to Earth. Situated just over 4 light-years away in the habitable zone of its star, Proxima Centauri, this discovery has sent shockwaves of excitement and curiosity across the globe. Could this be the moment when humanity finally discovers that it is not alone in the universe? This momentous breakthrough began with NASA's powerful telescopes, which have been meticulously monitoring distant stars and planets for signs of life. Proxima B has long been a primary target in the search for extraterrestrial intelligence, SETI, due to its Earth-like characteristics and proximity to our solar system. The signal detected from Proxima B is unlike anything astronomers have observed before, making it a possible turning point in human history. The implications of such a discovery are profound. First, it validates the long-standing scientific hypothesis that life could exist on other planets, particularly those that share Earth-like conditions. Second, and perhaps more intriguingly, it raises critical questions about the nature of the civilizations that might reside there. Could they be mere microorganisms, or could they be advanced beings with the ability to engage in interstellar communication? This signal from Proxima B is not merely a random noise or a natural cosmic phenomenon, it exhibits a structured repetition that suggests an intelligent origin. NASA scientists, in collaboration with international teams, are now working tirelessly to decode this message, trying to understand its content, and the intentions behind it. The global scientific community is buzzing with theories and speculations about what the message might contain. Is it a greeting, a warning, or something entirely unimaginable? The news of this discovery has transcended the confines of the scientific community, sparking debates on social media, in government halls, and around dinner tables worldwide. People are once again looking up at the stars with renewed wonder, pondering if beings on Proxima B might be doing the same thing on their distant world. How similar or different might their world be to ours? What would their society be like in terms of technology and culture? These possibilities seem as vast as the universe itself. Moreover, this detection raises a host of ethical and existential questions. How should humanity respond if the signals indeed come from intelligent beings attempting to communicate? What protocols should we establish for extraterrestrial diplomacy? And most importantly, how would such a discovery reshape our understanding of religion, life, and our very identity as human beings? While excitement is growing, there is also an air of cautious skepticism. NASA, and other space agencies are diligently working to validate these findings, ensuring that the signal is not a false positive or a misinterpretation. We are on the brink of what could be the most significant discovery in human history, and as such, the next steps must be taken with precision and responsibility. The world awaits with bated breath for more detailed analyses, and the stakes couldn't be higher. The detection of alien signals from Proxima B propels our scientific efforts into an entirely new era, one in which humanity is united by a shared curiosity and hope. Perhaps we are finally on the verge of answering one of the oldest and most profound questions: are we alone in the universe? The Proxima Centauri region, and the signal's origin. In April 2019, a radial signal was detected coming from outer space, specifically from the Proxima Centauri region, located 4.37 light-years away. While this might seem a considerable distance, Proxima Centauri is actually the closest star system to our Sun, residing only about 3 times farther than the third brightest star in our sky, Alpha Centauri. The signal originated from a triple star system, consisting of the binary pair of Alpha Centauri A and B, as well as Alpha Centauri C, also known as Proxima Centauri. Alpha Centauri A and B are relatively close to each other and bear striking similarities to our own Sun. Alpha Centauri shines with a yellow light, and is 1.5 times brighter than the Sun, while Alpha Centauri b has an orange hue and is half as bright. Alpha Centauri A is slightly larger than our Sun, whereas Alpha Centauri b is somewhat smaller, making it an intriguing object of study in the search for exoplanets. The groundbreaking Breakthrough Listen project, which is dedicated to searching for extraterrestrial communication in the universe, has identified this signal as Breakthrough Listen Candidate 1, BLC1. With an investment of approximately $100 million, the project has utilized thousands of hours of observation with state-of-the-art telescopes around the world to search for signs of extraterrestrial life. The signal was detected by the Parkes Radio Telescope in New South Wales, Australia, which was observing the region of Proxima Centauri when the signal was found. Incredibly, this signal almost went unnoticed among the vast volumes of data collected by the telescope. The scientific team, however, managed to identify it, like a needle in a haystack. For a signal to be considered significant, it must exhibit two key characteristics: it must be confined to a narrow frequency range, since such signals are not naturally generated in space, and it must fluctuate according to the relative motion of the exoplanet with respect to Earth. The researchers had to sift through nearly 4 million individual signals captured by the telescope in Australia. After a painstaking process of filtering and eliminating irrelevant data, they identified 5,000 distinct signals, one of which stood out, an unexplained signal that could not be traced back to contemporary radio transmitters on Earth. This unique signal, with a narrow-band technological signature, only appeared when the telescope was pointed toward Proxima Centauri, and it was observed over a 30-hour period. Upon further analysis, it was determined that the signal likely came from Proxima B, an exoplanet discovered by astronomers in 2016 using the radial velocity method. This method detects variations in a star's position caused by the gravitational pull of orbiting planets, with the star describing a small circle as it moves. Spectrographs are used to measure the shifts in the spectrum of starlight, which occurs when the star's light shifts toward the blue as it approaches a planet and toward the red as it moves away. Upon closer inspection, Proxima B was found to be strikingly similar to Earth in terms of size and mass. It has a radius 1.1 times that of Earth and a mass 1.3 times greater, indicating that it is likely a rocky world with a similar density to our own. However, there are significant differences between the two planets. The first notable difference is the location of the planets in their respective solar systems. Proxima B is much closer to its star, only 0.05 astronomical units, while Mercury orbits at a distance of 0.39 astronomical units from the Sun. This proximity would make Proxima B an extremely hot planet, but because Proxima Centauri is a dim red dwarf star, Proxima B receives only 60% of the energy that Earth receives from the Sun, placing it within the habitable zone where life could potentially exist. A new era in exoplanet exploration. As we continue to discover and catalogue exoplanets, we are only beginning to scratch the surface. So far, over 4,935 exoplanets have been discovered, and in March of this year, 65 new planets were added to the tally, bringing the total to over 5,000. This marks a milestone in planetary exploration, particularly with the advancement of the James Webb Space Telescope, JWST. The JWST is the most advanced telescope ever built, being 100 times more powerful than its predecessor. With its help, we will be able to unlock the mysteries of the vast universe. Through its observations, we have discovered a wide variety of planets, everything from small rocky worlds to gas giants larger than Jupiter, as well as planets that are extremely hot, and others that may harbor life. One of the standout discoveries is Kepler 1649c, a planet with characteristics strikingly similar to Earth. In fact, it is the most Earth-like planet we have found so far and could potentially support life. To date, we have identified 55 planets that could be considered Earth-like, but we have yet to study all of them in detail. With the rapid advancement of technology, particularly the JWST, there is much more to discover. One of the main goals of the James Webb Space Telescope during its first year of science missions is to study exoplanets beyond our solar system, focusing on how they form and whether they have the potential to harbor water and biological life. Webb's infrared capabilities allow us to observe and capture the early stages of star and planet formation. The ability to detect infrared light, which can pass through dust clouds that visible light cannot, makes the JWST an ideal tool for observing newborn stars that are still hidden within their natal clouds. These infrared capabilities are essential because they allow us to capture the first stages of star formation, when gas and dust are contracting to form new stars. Webb will also investigate the formation of giant planets, which begin as large, swollen structures that gradually cool and contract over time. In addition to studying stars and planets, the JWST will search for hot molecular gas around young stars, a potential sign of the formation of habitable rocky planets. As the JWST continues its mission, much of its early science work will focus on understanding how planetary systems are formed and the molecular components that may be essential for life. With the help of this remarkable telescope, we are closer than ever to answering the fundamental question: is life out there, waiting to be discovered?